In this video, I'm going to solve this question. In how many different ways can the letters A, B, C, D, E, F be arranged such that these conditions are satisfied? So the condition in part A is A and E are always together, and the condition in part B is A and E are always together and E comes before A. So let's start with part A first. So we have to find different arrangements of these 6 letters and we have to make sure that this condition is satisfied. Note that if I ignore this condition for a while, then this question becomes really straightforward. So if I ignore this condition, all we have to do is we have to find all the possible arrangements of these 6 different letters. And we know that can be done in 6 factorial ways. Now let us see how will the answer change if we have to make sure that A and E should always come together. So to make sure that the condition in part A is satisfied, we have to look for the possible arrangements like these. So one possible arrangement could be this B, D, A, E, F, C. Another possible arrangement could be this, and so on. So we have A and E here together and we have A and E here and so on. So these are the kinds of arrangement we have to look for. We have to make sure that A and E are always together. The other 4 letters can be arranged in any way. Now let's see how can we solve this question. There are many ways to solve this particular question, but I'm going to work with the simplest and the intuitive method. So let's start. So we have 6 letters A, B, C, D, E and F, and we have to make sure that A and E are always together. So the first step that you have to do is you have to assume that A and E are one element, as they have to be always together. So what I'm trying to say is that instead of these 6 different letters, what we have are these. So we have B as one letter, C as one letter, D as one letter, and then A and E as one letter and F as one letter. So I have combined A and E and I'm going to treat A and E as one element. So if I do this, then how many different letters do I have? Well, now I have only 5 different letters. This is my first letter, this is my second letter, third, this is my fourth letter because I am treating A and E as one element, and this is my fifth letter. And all these letters are different letters. Now we know that if you have to find the number of arrangements of 5 different letters, then it would be 5 factorial. But this 5 factorial is not our final answer. There is one more step that we have to do before we come to our final answer. And let's see that additional step. So if I'm working with these 5 letters, the possible arrangements that I can have are B, D, C, A, E, because A and E are combined and they are treated as one letter, F. Another possible arrangement could be F, D, C, B, A, E, because we have taken A and E as one element. Now this 5 factorial includes all possible arrangements like these. Now the problem is that A and E can also be arranged in 2 factorial manner. So I can write one more outcome by just interchanging the positions of A and E. So I can write another possible outcome could be B, D, C, and instead of A, E, now I have E, A, F. Now this particular outcome is not a part of these 5 factorial outcomes. Similarly, if I rearrange this outcome, I can write that this is F, D, C, B, E, A, and once again this outcome is not a part of these 5 factorial outcomes, because when we are calculating these 5 factorial outcomes, we have considered A and E as one element. So when we are making 5 factorial possible arrangements, everywhere we are writing A first and then E. But A and E can be arranged in 2 factorial ways. Instead of AE, we can also have EA. So now we have to also incorporate for these outcomes. So now to get to the right answer, all we have to do is we have to multiply 5 factorial by 2 factorial. And this is your final answer. Note that you understand this well. So what I have done is that we were given 6 different letters A, B, C, D, E, F, and the condition was that the A and E should always be together. So I treated A and E as one element, and in this one element that I have created, I took A before E. And now because I'm treating A and E as one element, so the total number of letters that we have now are 5, and these are 5 different letters. Now we know that the 5 different letters can be arranged in 5 factorial ways, so we get 5 factorial. And because A and E can be arranged in 2 factorial ways, so for every outcome that you have like this, you can also have an outcome like this. So that's why, to take into account that possibility, we have multiplied 5 factorial by 2 factorial. And this is basically because A and E can be arranged in 2 factorial ways. So that's why we have to do this additional step. So this is the final answer that we get, and this is all for part A. Now let's move to part B. So according to the condition in part B, we have to make sure that A and E are always together and E comes before A. Well, let me make a small change here just for the sake of simplicity. Let's say that this is A comes before E. This way I will not have to write the things again. So the part B is A and E are always together and A comes before E. Well, this is simple now because the condition in part number B says that A should come before E. That means we cannot have these kind of arrangements. We can have this and we can have this, but now because A should come before E, that means these two and similarly the other outcomes in which we have E before A are not a possibility now. So in part B, your answer would be 5 factorial and you will not have this 2 factorial for part B. So the answer for part A is 5 factorial multiplied by 2 factorial, because in part A you can interchange the places of A and E, and the answer of part B is only 5 factorial because in part B you don't have the liberty to interchange the places of A and E. So I hope this method of solving this question is clear now. So this is all for this lecture. I will continue with this question in my next lecture, and there we will do an additional case.